Although you could view each analysis within the network, you might want to compare the explore and validate analyses directly. This tutorial will show you how to perform this type of comparison. Click Node on the ribbon. Click Unconditional Statistics. Select SPY as the node. Then click and hold the left mouse button down on the top of the statistics border. As you hold, move the mouse to the top of the screen and release. The statistics menu should follow your mouse and change position to the top of the list. Click on the plus button next to statistics. This should expand the statistics container and show the graphics. Notice that the results for the Evaluate and Explore column are identical. This occurs because the initial Evaluate data is set to be the Explore data by default. The Evaluating Forecast Guide will show you how to set the Evaluate data appropriately. Click the minus button in the bottom right corner to collapse the statistics display. Similarly, the scores in unconditional probabilities and expectations are exactly the same as those shown in the network. Click the Node button on the ribbon. Click on Time Series. Select SPY as the node. Click the plus buttons next to the Returns Charts, Cumulative Returns Charts, and Rolling Standard Deviation charts. The graphics show the graphs of the Explore and Validate returns plotted over time. The Validate Returns graph only contains a sample of 1,000 observations rather than the full 10,000 simulations. This ensures that it is readable. Comparing the Explore and Validate Returns graphs enables you to verify that the roughness of the Validate returns is close to that of the Explore returns. The Validate cumulative returns are rougher than the Explore cumulative returns. Although the simulated data differs from the historical, it is still plausible. Unless you are forecasting significantly higher market volatility than the historical period, the Validate rolling standard deviations should typically fall within the range of the Explore rolling standard deviations. In this case, the simulated data is at the upper end of the historical range. This observation aligns with the intent to make the forecast slightly more volatile than history. This tutorial has explained how to verify the plausibility of unconditional forecasts using single analyses. All of these analyses can also be used to verify conditional forecasts as well. In the Creating Conditional Forecast Guide, you will learn additional techniques for creating and verifying forecasts for child nodes.